Recording.
Wait, don't
Thank
start.
you.
Oh, shoot. Okay. Okay. Hello. Hello.
Jesse, we can stop recording and record it again, okay? Are you not ready?
Yeah. Okay. Yeah, I'm ready now. I'm ready now. Okay. Okay. So last week I released the assignment. And this week, as promised, I'm going to go over the solution. So don't worry if you didn't figure out all the questions. And also, when I ask for questions, because I know like lots of people like me personally don't want to be like the voice in the recording. So you can just like private message me in the chat if you have like insight on the question, I guess. So to get started, right, so you can press Shift Enter to run a cell, just like a quick thing. Okay, so to begin the assignment, let's create a new data called ice cream. So this ice cream table, you don't really have to worry about this notation, but I think it's at least hopefully quite intuitive, right? So you have three columns, right? You have the flavor, the color, and the price. So you can imagine this chocolate ice cream is $1 and the color is brown. So task one, the basics. Add a column of integers containing 1, 2, 3, 4 called rating to the ice cream table, which expresses your personal rating of the flavors. 1 is best, 4 is worst, aka mint chocolate. And there's no right order, just make sure you complete your choice of rankings. So would anybody like to give me their ranking for food? Okay, thank you. That's okay. So yes, as this person has commented, rating, right? And they chose the order 1, 4, 3, 2. Okay, great. This is actually perfect. I perfectly agree with this order, by the way, because mint chocolate is for sure the worst. Note that this person also casted their series. Casted their series. Or casted their list into a series to become the column. Right. So we have our rating column was 1, 4, 3, 2. I'm not even sure if this casting is necessary. Let me test it out. Right, it's not. Okay. Yeah. But Pandas is like very smart and like the way they handle things. So you can just assign a list to it and it'll automatically assume you're creating a new column. Right. So this is like, as a quick reminder, this is like the basic column notation, right? If you guys remember from way back when we did, it was like one of the first two lectures, right? Okay, actually, yeah, this is the exact same rating I had. 1, 4, 3, 1, 2, 3, 4, right? Chocolate is of course the best. And mint chocolate people, they probably don't brush their teeth very often, is all I have to say about that. Okay, but right now our column names are ugly. Right, so you can use rename, the rename function to change the column names so that they start with a capital letter. Assign this to a table called ice cream cap. So if we look at the function .rename, pandas, right? You call it on a data frame. You put your columns, but you can also put in a dictionary. And this is like sort of I'll sort of give you like a fancy solution here, right? So where we can have our ice cream table, we can call .rename. And if you see the index, you can put in a dictionary where, let's see if they have an example here. They do, right? So I can rename, oh yeah, I can rename A as, or this little a as big A and this little c as big B. Sorry, it's the other way around. Right. Okay, sorry. We can name the column A as this little a and this column is big C. So we can just like sort of do this all at the same time, as opposed to doing one at a time, right? So how this would look like is just columns equals, and then my column name, and then what I want to rename it as. And this is a Python dictionary. If you're unfamiliar with that, you don't really even need to know how to use this. There's only like 2 instances where this shows up in Python or in pandas, and this is just one of them. And it's like you can just do it one at a time as well. Right, flavor is one of them. Oh, I've got the auto thing, nice. And then what's the last one? Rating. What's the last one? Okay, nice. So now our 4 traits are capital, right? So now our table looks nice. And this rename function, if you're working with real data, the person who named the data is probably not, well, like you're gonna have to create your own columns, right? So renaming is actually like a very important aspects of like tables, right? Of like readability, right? Okay, so question 1C. Oh no, Jesse, so I'm assuming me, hates mint chocolate ice cream. So use .lock or .ilock function to remove mint chocolate from the table. Assign this new table to a new table called mint. Okay, so I guess does anybody have an idea on how to start this? Okay, I would just copy and paste this guy's code who just gave it to me. Right, okay, so this lock is basically saying I want 0, 2, and 3. Right, so this basically saying I want 0, I want row 2, and I want row 3. I put this, you get this nice table here. Okay, however, there's like a minor difference between this table and this table, if you notice, right? Notice the hint, don't forget to read the state index, right? So now we have index 0, 2, 3. So now if I, for example, want the first index of the table, I'll get an error, right? Let's see if I can get the error right now. Exactly, right? So like even though there is like a 1 index thing, or like 1 index in the original table, because I've not relabeled my index, it still thinks it's 2, right? So if I want 2, instead of getting like the first index, I'll get, okay, I completely lied. Okay, anyway, we need to reset the index. Right, so if we call our function reset index, right? Okay, but now we unfortunately have 2 index columns, right? And we want this like nice pretty table here, right? So we can just use the drop method or index, and then we have to specify the axis, right? So we're dropping a column basically instead of a row. You can also, so to get this like final table, right? So notice you can also use ilock. Oh, let me. Okay, there we go. Hopefully this is better. Okay. Okay, so now we can see. Sorry about that. Okay, so there was a question in chat which asked if I could use this code instead to let's just add let's just test this alternate solution, right? Right, so this table, I assume you meant like this, right? Hmm? Partial type. Wait, why does? Okay, live debugging never goes well. Oh, sorry. Okay. This is what I assume you meant. Okay. Okay. Yeah, so with this code, you notice our indexes are sort of wrong, right? We go like 0, 2, 3. Because we sort of like forcefully remove the first column. So this is why I want to go through this although like kind of extra code to sort of reset it to the 0, 1, 2 idea. And the reason why you I guess want to do this in real life is because you sort of want to keep things consistent or like indexes consistent. So like you sort of don't want like holes basically in your indexes. Okay. So now that we have this, so 1D. So the ice cream store has experienced the detrimental effects of inflation. Right? They're very sad and very real these days. I paid like $8 for a frozen yogurt. Okay, it was like not okay. Anyway, so add $1, then square the price of all values in the price column. And make sure to replace the old price column and make sure to use the no mins table. Right? So we're just gonna immediately say take the no mins table, right? So we want to do like the convenient addition, right? So if you remember correctly, or if you remember from like the previous lecture, if I simply do this and I simply output this, I will get the price column with but added 1, right, as a series, right? So this question is basically asking, I want to add $1, then square the prices of all the values in the price column. All right, so how would I square this? In Python, it's just a double asterisk, double star, right? Okay, so now 2 squared is 4. I forgot what number there's it with here. 1.35 squared is 1.8, and so on, right? So now I very simply just have to assign this to the price. I want to overwrite the price column, right? Because I don't want like the old price column in the table. And then I simply want to output in my table. Okay, so what just happened? Why is it all of a sudden 25 and not what it used to be, which was like 4? So what happened is that the pandas notebook has memory, which means that like I created a no min price, but then I sort of reran the block of code again, right? But pandas, or the notebook, sorry, it's not pandas specifically, it's notebooks, has memory of me running it twice. So basically what happened is that I made 4, then I reran the code, but I saved it, right? So then instead of 4, it became 4. Instead of like 1, it became 4, and then I ran it again, so it became 4 plus 1, and then squared. So that's 25. And so if you want to reset this, I sort of just need to redefine my no mins table. And this is actually a very important lesson that I just randomly created. Whenever we create or like add a new column or something, we normally want to rename it to something else, right? For this exact problem that just happened, right? Where you like sort of do things twice and then like pandas like has invisible actions that like happened previously that you like didn't mean to happen, right? It's not like Python code where like it reruns everything every iteration, right? If you ever find yourself, that's why if you ever find yourself like trying to debug for like an unexplainable issue, everybody's go-to is just to restart the kernel. Basically restart the entire program and start from the top, right? Because there could be like these type of issues. And very nicely, this table matches exactly right. So that was like sort of the basic introduction, right? So this is like sort of hopefully a review of how we can create a new column, how we can rename columns, how we can use dot lock, and then after using dot lock, we can reset our index to sort of get back to the 0, 1, 2 idea, right? And how we can do math or like modify a column, right? Okay, so now we go into task 2, baby names, right? We, at this point, are very familiar with this data set, right? Where we have the state, we have the gender, we have the year, we have the name, and we have the count of the people who were named that, in that year, right? And yeah, make sure it looks like this, just to check the loading. This assert just means it'll error if this is not true. This is sort of out of scope, but it's just like a nice little tidbit. Right. So this question, I think this section, I purposely wanted to talk about Boolean expressions a lot, right? So recall that the baby names dataset contains a record of given names of babies born in the United States each year. The next two questions will be about Boolean arrays. Recall the following table. I don't know why I said recall. I'm not sure if I've ever shown this table before, but this is like sort of a very nice table to look at, right? Where equals is how we use it, right? And the meaning is does A equals B, right? With this greater than less than, yada yada. This is not in pandas. This is the or, this is the and this is the XOR, the exclusive OR, which you don't need to know what that is. Okay, 2A. I'm curious about the total number of people named Alan in California throughout the years. Use the baby names data frame to sum up the counts of all people named Alan in California. Okay, so how do we start? Intuitively, we want to use the Boolean array, right? And this is like sort of a dead giveaway that I want everybody named Alan, right? So what is the column we compare for names? Well, I mean, it's the name column, I would assume, right? So we can take baby names. Then we want to create a Boolean array right here. And how we do that is we call baby names. Then we have the name. We have it equal to Alan. And again, hopefully this is some review of what we went over before. Okay, so now what is this output? Now we have only the entries with Alan. Right, so now I simply just need to sum up this entire column right here. Okay, right, exactly. We can just simply select a column like this and then call sum. Right, and there were a total of 20,000 Allens born with the double L-E-N, right, in California since 1910. Note that you can also use like np.sum here, and like numpy sum. It's all the same thing. This is Pythons, and this is just this one was just Pythons. This one is just numpys, right? So this is sort of like a quick thing we can do with the baby names data, right? If you want to compare, like for example, Jesse, I can just do this as well, right? There are more people named Jesse than Alan. That's actually quite surprising. And then Nathan, the trio of brothers. Of course, there's way more people named Nathan than the other names, right? Okay, 2B. Using Boolean arrays, select the names in the year 2004 from memories that have larger than 3,000 counts, right? So instead of just one condition, now there are two conditions. And per usual, right, we can just do this. We can just do the exact same thing. We can just do one condition at a time if we want. So how do I make sure that everything is in the year 2004, right? I simply just look at our table, baby names table. Okay, what's the year? Okay, well, it's just called year. Okay, so I assume that's what we're comparing. And 2004, right? So what does this give us? Why is it empty? Oh, right. Okay, the data type matters. Okay, so I was looking for the string 2004, but it should be the number 2004. Right, so because the year, if you look at the year column, well, baby names, things describe. Okay, it was not describe. It was another one of the commands that shows the data types that I've forgotten. But yeah, anyway. Oh, okay, I think I can show the series. Okay. Take two. Okay, nice. Yeah, in 64, right? So they're integers instead of strings. So what if I try to match an integer with a string, I'm not going to get any matches, right? So that's what happened. So now that we have baby name 2004, I can very similarly just apply my second condition right here. That's my new table, right? Where counts, right? So it's count is over 3,000. And we get this final table that matches exactly. A nice shortcut we can do is just very nicely use this AND operator right here, right? So we can just run 2 at a time. And this should, let me make sure the AND knows what it's ANDing with parentheses. Okay, and nice. And we should return the exact same table, right? It was just one line of code, so it looks nicer, I guess. Right, and I put this table in here so you can like double check that you have the right answer, basically. All right, so 2C, create a table using baby names with 2 columns, 1 with the year, and 2 the count of the people who were born that year. And the hint I gave you guys was, we've actually done this in lecture, right? So if you guys remember the first graph I ever showed you guys, it was done with this exact code. Okay, so does anybody have any idea how to solve this? Okay, nice. Yeah, okay. So baby names, then dot group by. Yeah, okay, year, right? So this is basically saying, I want everybody to group by year, then I want the sum, right? I want to aggregate with the sum of the count, right? So how do I do this? I can do dot.ag, exactly, .ag sum. Okay. I know I purposely omitted something from your solution, but it's just to like prove a point, or like just to show something that could like potentially go wrong, right? Okay, so like what happened, right? So we notice we have a count column that's correct over here, right? But what is happening is all these other ones, right? So when you sum string type objects, it'll concatenate, which means it'll just add it to each other, right? So if you notice, this is just CA plus CA plus CA plus CA. This is just F like added a bunch of times, right? And this is like all the names of the people who were born in 2010. Right, so how do I get rid of this? I can either call dot drop, or I can select the only 2 columns I want, which are year and count. Just like, right, okay. The reason why this doesn't work is because, if I show you guys right here, the reason why that did not work is because this year column is our index. So it's like, this was looking at our columns and was like, why don't I see a count, basically? Or why don't I see a year? And it's erroring out. Notice that we can move this over here as well. And then we can also just simply call group by on these 2 columns only. Right, so we have like a variety of options. I'll go with this is probably the most standard version. I would say people put it like right after the group by. I'm not entirely sure why, it's just like, I don't know. Just what people do. Right, so notice these 2 tables matches, right? So that's the solution, right? And this is sort of one of the most basic applications of the group by, right? And so this is like why this was like the first example. If you're still a little confused about what group by does, make sure to go back to the slides and look at like the graph, or not the graph, like the image. That image like will sort of give you intuition on how to do it, right? Okay, 2D. A challenge question, or at least I personally thought it was quite hard. Output the name with the most total count throughout the 2000s, year 2000 and after, in the baby names table, right? So right off the bat, we're gonna have to like quite a bit of operations, just like from this it's the sound of it, right? So like very first off, the very first thing we should be looking at is that it's got to be year 2000 and after, right? So immediately our new table should look like so immediately we should be looking at this table here. Oh, I am goofing up, as they say. I completely just forgot the syntax. Okay, there we go. Okay, we're back. Yeah, that's just a very silly syntactical error. Anyway, so now we should be looking at only the years 2000, right? Now, how do we get the name with the most total count? Right, but if you remember from 2C, this is exactly what we just did, right? We literally just got the total count, but not of the person, but of the year, right? So you can imagine our code would be very similar to what we had before, right? So instead of grouping by the most, instead of the year with the most total count, we can output the name with the total count, right? So if I think I can just literally copy and paste this code right here. Instead of grouping by year, I simply group by name. Right, so now, after 2000, there were 18 people named Aiden. That's a unique spelling of Aiden. And there were 103 people named Zyra, right? Okay, but now, how do I get the most total count? So how do I get the largest number in this count column? And finally, how do I get the name of the largest count, right? So to get the largest count, there are many ways to get it, right? You can like call a max maybe and try to look for the number, or what sort of pandas supports, right? We can just call dot sort values. And we can sort of, I think if I remember correctly, and hopefully my machine allows it, you can sort of like D-line it with this parentheses. I guess we'll figure out if this works for now. Okay, so what are we sorting by? Okay, the count column, right? I mean, there's nothing much to sort by. Ascending equals, and instead of this one, we want false. Right, so now it's sorted. Okay, yeah, so this notation actually works. Okay, so if you ever see like your one line of code is like going too long, you can sort of split it into separate lines with these parentheses, right? And most common notation will look something like this, maybe, if it's going too long, where you just have like every single new function call on a new line, right? So it sort of looks nicer. Okay, so now we have a sort of account. So the most common name after 2000 in California was the name Daniel. And so how do we extract the name Daniel? We can just call dot indexed and then the zeroth index. Oh, it was dot index. Okay. Okay, yeah. So in the previous example, when I was talking about like the ice cream example of when we had the hole and the one that would error, if you call dot index, actually, you know what? I can just show it. Yeah, so right here when we had the hole, if I call no mint dot index 1, Okay, I completely lied. Okay. My point is index 1 return 2, which is what it's not supposed to. Okay. Anyway, I guess we move on. Right, okay. Well, back to what I was saying. So in this question, 2D, it's like sort of a three-part solution, right? Where you filter, then you group by, then you sort, then you extract the information you want, right? So this is like sort of like a culmination of a lot of the stuff we learned in pandas. Okay, task 3, the final task. Let us merge. Okay, so I've introduced this new elections table where we have the year, we have the candidate, we have the party of the candidate, and then we have the popular vote, the amount of people voted for them, and if they won or not. This is like one of the most famous elections or the most famous robberies, right? Where John Quincy Adams, despite losing by like 40,000 votes, somehow still won the election, right? And it was like not even close actually, right? Because he got the most. What is the system called in America? I completely blanked. Okay, well, anyway, you get like points by state. Okay, wow, I cannot believe I forgot. Anyway, I swear I'm American. Okay, anyway, yeah. I'm sorry, what was it? Okay,
Like
anyway.
the Electoral College?
Yes, Electoral College. Thank you. Okay. I don't know why I completely forgot the name. Right, so like John Quincy Adams won through this Electoral College, right? So this is what this table is kind of showing. If you look later on the table, Donald Trump has a very similar story, right? And I think this has only happened like very few times in American history. Right. Okay. So anyways, so that's what the elections table is. That's like sort of off topic. Okay. So 3A. Create a series object that shows the best percentage for every party, sorted in decreasing order. Only include a party if their max percent is more than 10. So what this intuitively means is that for every party, give me like the biggest amount of popular votes they ever got in history, right? So if we look at the final series, this is like what it should look like, where like the biggest percentage ever won by Democrat was 61.3. And if you look like further down, the biggest percentage ever won by like a Southern Democrat was 18.1%. Right. So how you get started is this. I mean, this is a very key line here. Only include a party if their max percent is more than 10. Right. So immediately our Boolean array bells should be ringing, right? Where I simply just only keep the ones where it's greater than or equals 10. So if we look at our current state of our current table, right? So notice how, okay, this is not very informative because all these are greater than 10, but yeah, this should be filtered. Let's see here. Okay, yeah, it should be filtered, right? Where there's not a single thing about 10%. Okay, but then the next key phrase, I guess, is this for every party, right? So notice that means I have to group by every party, right? Because otherwise I won't be able to make decisions about the entire party, right? Because notice it's like split into multiple rows, right? So intuitively, the next line will be dot group by, right? And by party. Now, what do we aggregate by, right? I want the best percentage. Okay, well, what is the best percentage? Well, it's just the largest. And what is the largest? Well, it's just the max. Right. So out of all the Democrats, if I group them all together, imagine like the mini subtable for him. What's the largest value of all of them? Well, that's exactly what dot max is. Right. However, I do not really want to call dot max on popular vote or result, right? because that I like in our final series at least does not have this value. Right, so I can just very simply extract out the percent column. So let's look at our current state right now. Okay, so now we have our series. Notice that if I put a double bracket here, I'd actually return a table, right? So like notice the key difference, right? Syntactical difference. All right, so now we have our series here, and it's only a series because for the question I was feeling weird and decided I wanted to return a series. Okay, so now and this other key phrase here, sorted in decreasing order. Okay, well, how do I sort it? We saw this earlier, right? With the dot sort values. What if I just copy and paste this right here? And again, our code is getting kind of long, so I'm going to do exactly what I did before. It's a very nice notation. Right, so dot sort values, and then what do I sort by? In a series, I actually do not have to specify what to sort by because there's only one value, right? Okay, so nice. And so now we have our final table with our parties sorted, right? So if you notice, if your favorite party does not show up on this list, sadly, they have not gotten more than 10%. I think an example would include like the Green Party. I guess they've never gotten 10% of the popular vote. Okay, 3B. This question will help you learn how to read documentation, right? So use string.split and create a new column in the elections called first name that's equal to the candidate's first name. At the time of making this assignment, you guys had not learned what string.split does, but I sort of went over it last week. But I guess that's okay. So, right. So the idea or my final table, I want to create this column, which is called first name, right? Which is the first name of every candidate. So I guess, how do I get started, right? So like, well, first of all, I need to create a new column, right? So how do I create a new column? I take my elections at first name, then I just say first name. Right? So now I have to assign this to the first name of every candidate. So how do I do this? Well, I first of all need to look at the candidate, right? The candidate column. Then I need to do a string operation. So if we look at our string.split documentation, I think you guys can still see my screen, right? If you look at this .string.split documentation, right? What the string.split does is that it splits the string by your specified character. Where's the example? Okay. Yeah, so the default is like a space, right? So if I look at this, I split this into this is a regular sentence, right? There's also a regular expression split. I guess that's not as important. Okay, so I can call .string.split, right? So how do I want to split this? I want to split, of course, by the space, right? So space. So now what will this return? Now my first name column will just have a list of all the splits, right? Notice that .split returns a list, right? Even if it splits nothing, it will just return the entire string in a list, right? So how do I get the first name out of this list? This is just like a Python idea, right? Where you like put this bracket. However, this will not work because this itself is like a series, right? So this will actually return that, which is not what I want. So instead, I want to vectorize it with this .string operation, right? which will allow me to sort of treat everything in this table as like a vector, and then I can call this 0. And then you see we got our final table. In hindsight, now that I've done this problem, this one is probably, oh yeah. Well, in hindsight, my challenge problem was not that challenging because these questions are a little harder, but that's okay. So, okay. Below, I've created the baby names 2022 for you, which is the naming kind of every names, but only in 2002. Right, I've only kept the name and the count. This is just a very fast, or like a shortcut, right? I just sorted it for you. And because I want to merge the baby names table with the elections, right? To see how popular the president's name was. Now, if we look at this merge, where's my Chrome tab? Okay. Anyway, pd.merge. Right. So it takes in, you can call data frame.merge, and you take in a right, then you take in left on, then you right on. You can also call pd.merge, which is like a sort of different syntax. Right, yeah, so you can call data frame.merge, or you can call pd. Where's pd? Okay, anyway, I'm just going to implement pd.merge now because I can't find it. But what you can do is pd.merge. Right, and you sort of specify your left table. In this case, since you call on the left table right here, you only have to specify the right table. Right, so what is our left table? Well, if we look at here, this final table, what table is on the left? Right, okay, well, it's a baby names table, right? So I can just call left on, and then right equals elections with first name. This guy. Right, okay. Now, if we look at here, I need to specify what do I want to merge, which two columns I want to merge together. Right, so left on is the left column I select for the left table, or sorry, not the left column, the column I select for the left table. And right on is the column I select for the right table. Right. So in this case, I want left on. I want to merge on name, right? This is called name. Right on first name. And if I run this code, I should output my desired merged table. Right, and these two tables should match. Okay, nice. Okay, this is the last question. And this was actually 3D. This was actually one of the harder questions, or the hardest question. There were actually like a handful of you guys messaged me about how to sort of ideas and how to solve this one. Right? So this is a pivot table question, which is like a very niche concept where you're sort of grouping by two columns, but you're putting in this very nice format. Right? So this name popularity, right? Which is basically saying create a pivot table, create this pivot table before, right? Where I want the party on the here, and then I want like the popular vote if they lost, or like popular win on the two columns. Right. So if we look at pivot table documentation, I don't know why it opens my Brave tab, but yeah, pivot table documentation, right? So we can call pd.pivottable. So let's just copy straight up like what this is looking like, right? So we go pd and dot data frame, right? So we can just call pd, yeah, okay, pd dot pivot table, and we have our old table here, which is called name popularity. Okay, you know what? Actually, I'm gonna go the alternate way, which is right here. Okay, I completely lied. I don't know. I don't know what's wrong with the document. I just choose the wrong documentation, I guess. But again, data equals, right? If you see here, data or data frame here. Okay, so now I want to specify sort of what goes in my rows. And if we look at this example here, what will go into my rows is this value. Wow, this is like a really bad example. Why are they all so bad? Okay, sorry. Well, there's a column, so you can probably guess. Okay, it's not the values. Where is it? Where's the example? Why is the value? Okay, I'm so sorry. Let's backtrack a little bit. Okay, so what are my rows? The rows are the index. Okay, so this will, right? So these rows are index, right? So that'll be a party. Okay, so what are our columns in this case? So if we look here, the columns are very simply our result, right? Because if you notice this like loss or win here, and this labeling should sort of this labeling right here sort of gives away what our value is, right? So, well, I mean, right, where it's the popular vote. So it's the value of the popular vote when they lost and the value of the win of the popular vote when they win, right? So in this case, I should have renamed these columns. This is like totally gave away the entire question. But anyway, popular vote, right? So value equals popular vote. And I wish this documentation would tell me, but values must be list-like, which means it must be a list. So we can just have this list right here. Okay, so now how do I want to aggregate? Right, I want the sum of the popular votes in this case. So if you look at the pivot table, it's called ag_func equals sum, which, okay, in hindsight, I should have specified we wanted the sum, which I'm very sorry for not specifying. Yeah, and then finally, there's a fill table or fill value here, which just like, if it's missing, then what I want to fill it with. And in this case, it's 0, if you notice like these lists of zeros here. Unexpected. Oh, it's values. Okay. Okay, nice. And so now we output the desired pivot table. And that is the end of the assignment. Yay. I'm hoping it was not too bad. It was actually, I think, a little harder than I intended. So I apologize for that, especially this last question. I should have like specified a lot more. So next time I will make a better assignment, I guess. Thank you.